log of x in base 4 is equal to half log of x in base 2. Now, you can't work out logarithms which are in different bases. You need to make sure that they are all the same base. Okay? So what I'm supposed to do is to convert them to the same base. Now, the better thing or the best thing is to do is get to convert the one with a bigger base to a smaller base. So we're going to say log. We'll take this one in base 2, alright? I'll keep the x the same way it is. And then I'll also come down. Log. Remember I've changed to base 2. But what was the base now is going to be here. And then this one, I'm going to take it the other side. That will be minus 1 over 2 log of 2x there. Are we good here?
Yes.
Okay. Now you know that log of 4 in base 2 can also be written as log of 2 squared in base 2. And when you've got a power here, you can bring that down or in front. Now if you've got a log of a number in the same base, that gives you what?
1.
1. So this will be 2 times 1, which is just 2. So we're going to have a 2 in the denominator, right? So this is going to be log in base 2 of x. Okay, we have a 2 in the denominator. Now having a 2 in the denominator is the same as saying 1 over 2. Like it's the same. Okay, when I write log of x in base 2 over 2, this is the same as saying 1 over 2 log in base 2 of x. It's the same thing. And then we've got minus 1 over 2 log in base 2 of x. Actually, this one wasn't solved. It was saying show that. Okay, we want to show that. Now, half log 2, okay, half log 2x minus half log 2. Like you will know that when you subtract the same thing, you get a 0, right? So this is 0 is equal to 0. Hence, shown. So, that is it. We are good?
Yes. And I've seen where I didn't I got a bit lost.
Okay.
I would have I would have completed it because I only ended on log x base 2 over 2 log 2 base 2. So the only thing was meant for me was to reduce this one, which meant that to become log x base 2 over 2, which can be written as half log 2 base 2x.
Okay. Alright, so the next one is saying solve the equation log in base 2 of 2x plus 3 minus 2 log in base 4 of x, which is equal to log in base 2 of 2x minus 1. Alright, this is the equation. Now when you're solving logarithmic equations, make sure that all the terms with a log, you take them the same side. Right? So this is going to be log in base 2 of 2x plus 3. I'm going to take this one minus log in base 2 of 2x minus 1. Now this one you've seen is in a different base, so we need also to convert it to base 2. So I'll say minus 2. Okay, now the log x in base 4, I'll write it as log. I'm converting to base 2. 2. Write the same x the same way it is. Over, I'll write again log. Remember I've converted to base 2, but what was the base comes here. And that is going to be equal to 0. We will not have anything this side. And what is log of 2 in base? What is log of 4 in base 2? We already found this in the previous one. What is log of 2 in base? What is log of 4 in base 2?
Half log 2. Half.
No, I just want this
Half.
one.
Eh, eh, which one?
I just want a denominator. What is log of 4 in base 2?
Log of 4 base 2.
No, please,
I
please,
didn't try to.
please be serious. It's not about writing. Log of 4 in base 2 can also be written as log of 2 squared. These 2 will come in front, so that will be 2
Oh,
log
you meant that
2.
part.
So this is going to give you just a 2.
Okay.
So log of 4 in base 2 is a 2. And this 2 will cancel with this 2 which is in front here. So just remain with log of 2x. That is going to be equal to 0. So now you merge this as a single log. This is going to be log in base 2. We're going to write the 2x plus 3. Now this one is subtracting, meaning that this thing is going to come down, like logs of the same base subtracting. And when you've got log in base a of x minus log in base a of b, this is the same as log in base a of x over b. So just divide these two. So that's what we're going to do also for this one. The 2x minus 1 is going to be in the denominator. Okay, it's going to come here because these logs are subtracting. 2x minus 1. But remember also this one is what? Subtracting. Meaning that also the x is going to come where? In the denominator. Okay, but we already have something in the denominator, so also that one is going to come there. And this is going to be equal to 0. Is this okay?
Yes.
Okay, now you express this as as an exponential function. So this is the base, this is going to be the power, and should be equal to this one. So I'm going to say 2 to the power 0 is equal to 2x plus 3 over um over over this one. Okay, now write that as 2x squared minus x. Hope you can see that, can you?
Yes, I can.
Okay, so this is 2 to the power 1 is a 1. I mean 2 to the power 0 is a 1, and that is equal to 2x plus 3 over 2x squared minus x. Cross multiply. It's going to be 2x squared minus x is equal to 2x plus 3. Take like terms to the same side. 2x squared. If the 2x comes this side, becomes negative, so that will be negative 3x. Okay, and then the negative 3, and that is going to be equal to 0. So this is going to be what? We look for the product and the sum. What is the product here? What's the product? Can you get what I'm saying?
-6. The product.
Okay, product is negative 6, the sum is negative 3. Do we have any two numbers that we can multiply to get negative 6? When we get to add them, we get negative 3.
No.
No. So then the option is to use the quadratic equation. X is going to be equal to negative b, which is negative 3, plus or minus square root of b squared minus 4ac over 2a. And this simplifies to x being equal to 3 plus or minus, inside 3 squared is a 9, 4 times 2, that's 8 times 3 is a 24, so that we've got 9,
Yes, 24.
9 plus 24.
Yes, 24.
Okay, That is going to be a square root of a 3 over 4. So this is going to be the value of x. There are going to be two values. X is equal to 3 plus square root of a 3 over 4, or x is equal to 3 minus square root of a 3 over 4.